Hello students, how are you all? Welcome back to Akshar IT Foundation classes. I am your chemistry faculty S. Mohan. So, students, class 7 IT Foundation chemistry. In this volume 2, the last chapter, that is mole concept we are discussing, right? At the last class, we started the mole concept and completed the first synopsis. And the first synopsis, what we have learned? We have learned what is atomic mass, what is molecular mass, and we also discussed about the homoatomic molecules and diatomic molecules and how to calculate their molecular masses. This all we completed in the first synopsis. Alright. Today, students, we are going to complete second and third synopsis both together. Okay. So, with this, the IIT Foundation of class 7 syllabus will be completed for this year. Okay. So, today's our concept is mole. So, students, I think already you have learnt in the physics, mole means what? It is a SI unit to measure the quantity of matter, right? I think in this physics you might have studied about the SI units. There are 7 SI units, right? Fundamental units, sorry. There are fundamental units, 7 fundamental units are there, like mass, time, length, thermodynamic temperature, electric current, and the quantity of matter. Okay. So, this like this 7 physical quantities are there. In that, one of the physical quantities is the quantity of matter. And the quantity of matter SI unit is mole, right? So, in the chemistry, we to measure the quantity of any matter, means what are chemicals or anything, we use a concept called mole, right? So, what is mole? See students, mole means what? Here, it is like number, it is like mass, it is also like a volume. So, mole is the most convenient unit to express the chemical substances in terms of numbers, in terms of mass, and in terms of volume also, right? So, students, in the second volume, now if we can see what is 1 mole, first let us see. So, 1 mole is nothing but a, like already we discussed, I think, dozen, okay. So, dozen means what? 12. If you go to the banana shop and if you purchase, okay, or if you ask him to give 1 dozen of bananas, so he'll give 12 bananas, right? If you go to the fruit shop like apples, if you ask him 1 dozen apples, so he'll give 12 apples, right? So if you ask dozen pens, okay, pens, they'll give the 12. So dozen represents what? A particular number called 12. So similarly, here also actually mole represents that 1 mole of any, okay, substance consists of 6.023 into 10 to the power of 23 entities. What's the number? 6.023 into 10 to the power of 23 entities. Means what? 1 mole of any substance, okay, is equal to the number. It consists of 6.023 into 10 to the power of 23 entities. Means what number? Like for example, if I take 1 mole of carbon atoms, if I say like this, 1 mole of carbon atoms, then what does this mean? It means 6.023 into 10 to the power of 23 carbon atoms. Okay. If I say that 1 mole of hydrogen atoms, okay, hydrogen atoms. So, what does it mean? 6.023 into 10 to the power of 23 hydrogen atoms. Okay. If I say that 1 mole of hydrogen molecule, this is what? Molecule, okay, molecules. So, meaning is what? 6.023 into 10 to the power of 23 hydrogen molecules. So this is the mole, right? So here students here see, already in the previous class we discussed that the atomic mass unit, okay. So to measure the atomic mass unit, it is taken the carbon as a standard one, right? Carbon is taken as a standard one, okay. So carbon isotope of 12, so carbon 6, 12, okay. So this carbon is taken as a unit to measure the atomic mass, right? So 1 AMU, this already we discussed, 1 AMU is equal to 1/12 of C612 atom, okay. So if we take this atom, carbon atom, and if you break into the 12 equal parts, and if you measure the mass of each part, then that mass is equal to 1 AMU. Is this clear? This already we discussed in the previous class, right? Okay. Now, if you see here, now this carbon, okay, this carbon, if I take, 12 grams of carbon. Now in terms of, now see here, in terms of here, 1 mole of carbon atoms. 1 mole of carbon atoms means what? 6.023 into 10 to the power of 23 carbon atoms. This is called 1 mole of carbon atoms, because I said, 1 dozen means what? 12. So if I want 1 dozen of bananas means what? 12 number of bananas. If I take 1 dozen of apples means what? 12 number of apples. If I take 1 mole of some other thing, pens, means what? 12 pens. No. Similarly, 1 mole of carbon atoms means 6.023 into 10 to the power 23 carbon atoms. If I take 1 mole of hydrogen atom, 6.023 into 10 to the power 23 hydrogen atoms. Like this. Clear? Now, here 1 mole of carbon atom is equal to 6.023 into 10 to the power 23 carbon atoms. Right? If you measure the mass of this 6.023 into 10 to the power of 23 carbon atoms mass, if you measure, then very important students, here you will get 12 grams. How many grams? 12 grams. Clear? So 12 grams. Okay. Here 1 mole of carbon atoms means what? 6.023 into 10 to the power 23 carbon atoms. Okay. Now what is its mass? Its mass is nothing but 12 grams. Its mass is how much? 12 grams. Okay. So meaning is what here? What is its atomic weight here? 12 grams. So 12 grams of carbon. How many grams of carbon? 12 grams of carbon. Okay. Carbon consists of 6.023 into 10 to the power of 23 atoms. Clear? Okay. So that is a concept you need to understand. Okay. Now here you see now 1 mole of hydrogen atoms. So 1 mole means what, like dozen. Some same number is same. So number is, so 1 mole of hydrogen atom means what? Okay. 6.023 into 10 to the power of 23 hydrogen atoms. Clear? So now if I check the mass of this hydrogen atom, 6.023, which is equal to this number. Okay. But if I check the mass of hydrogen atom, what I'll get? I'll get only 1 gram. Approximately I'm telling. So it is 1 gram. What it is? 1 gram. Okay. So 1 gram of hydrogen atoms, if I take, that consists of 6.023 into 10 to the power of 23 hydrogen atoms. Or if I take 6.023 into 10 to the power of 23 hydrogen atoms together, and if I measure the mass of that one, I'll get only 1 gram. Right? Now you may ask, sir, here 6.023 into 23 carbon atoms, if it weighs 12 grams, how this same number of hydrogen atom weighs 1 gram? It's very simple logic, students. For example, if you are going to a banana shop and if you are purchasing 1 kg of bananas, okay, and if you measure the 1 dozen bananas, and if you measure the weight of 12 bananas, okay, you may get 1 kg or 1.5 kg, right? Now, for example, if I go to the shop and I ask 12 pence, 1 dozen of pence, does they weigh the same? 12 pence? No, 12 pence weight is different and 12 bananas weight is different. Yes or no? So similarly, here the number remains the same, but the mass will be different. Yes or no? Okay. Now here 1 mole of hydrogen molecules H2. So here 1 into 2. So this comes to 2 grams of hydrogen. Okay, 1 mole of hydrogen molecules mass is 2 grams. Clear? So it's nothing but a, okay, 1 mole of any substance of any atom is equal to its atomic weight. Is equal to its atomic weight. Means what? For example, if you take the carbon atomic weight is how much? 12. Atomic mass is 12. So 12 grams of carbon consists of 1 mole of carbon atoms. It was 6.023 into 10 to the power of 23 carbon atoms. If I ask what is oxygen atomic mass? Atomic mass of oxygen is 16. So 16 grams of oxygen if I take, it consists of again 6.023 into 10 to the power of 23 oxygen atoms and so on. Clear? So number is fixed and this number is called Avogadro's number. What is called Avogadro's number? Okay, Avogadro's number. It is denoted by Na. Okay, so this number very important, students. This number is denoted by. So you can see in material page number 101. The number of entities in 1 mole of substance is known as Avogadro's number, and it is denoted by N or Na. Anything we can write. Is this clear? And I think this concept also clear to you. 1 mole of carbon atom. Okay. Now, for example, you see here. Okay. For example, you see here. Here only will take. See here. Now, generally, in the chemical reactions, what we do. For example, I am telling. Which example? Okay. So, carbon plus oxygen gives rise to carbon dioxide. Right. So, here we have taken the carbon. So here before the carbon, is there any number? No. So the meaning is what? This is 1 mole of carbon. So what we can write the meaning of this one. In the chemical reaction, we write the chemical equations like this. The meaning of this one, how much carbon you have taken, how much oxygen you have taken to get the how much of carbon dioxide. Carbon burning oxygen to form the carbon dioxide, that you know. But how much carbon is required or how much oxygen is required? So how much carbon dioxide is released? How can we come to know? So here the carbon here there is no number, the meaning is what? 1. Okay, so 1 mole of carbon, the meaning of this one is what? 1 mole of carbon burns in, here also no number is there, 1 mole of oxygen gas, 1 mole of oxygen gas, and here also before no number is there, so to give 1 mole of carbon dioxide, the meaning is this one. So 1 mole of carbon burning in 1 mole of oxygen to form 1 mole of carbon dioxide. Is this clear? Now, for example, similarly, and if you write the stoichiometric equation, for example, magnesium, 2 Mg plus O2 gives rise to 2 MgO. So this is one balanced chemical equation. Okay. So here, before the Mg, what is there? 2 is there. So the meaning is what? 2 moles of magnesium. 2 moles of magnesium burns in or react. We can write anything. React, we write. React with here before oxygen number, no number. The meaning is what? 1. So 1 mole of oxygen. 1 mole of oxygen to gives rise to what? Magnesium oxide. Before what's the number? 2 is it. So 2 moles of magnesium oxide. 2 moles of magnesium oxide. Like that. Is this clear? So the meaning in the chemical equations is this. Okay. Now here, this 2 what is there? This is called a stoichiometric coefficient. What is called a stoichiometric coefficient? You know, in the mathematics you might have studied, yes or no? 2x plus 3y is equal to something. Okay, 2x plus some equations will be there, no? Okay, 2x plus 3y is equal to some 15, then something like this. So here x is variable and 2 is a coefficient, you know. Y is a variable, 3 is a coefficient, right? So like this, here also this is a coefficient and this coefficient is called, what is called? Stoichiometric coefficient. Okay. So here if you see 2 moles of magnesium. So the meaning is what? 2 into 1 mole, what are the number I said? 6.023 into 10 to the power of 23 magnesium atoms. Magnesium atoms. The meaning is this one, see, 2 moles of magnesium means 2 into mole means what? 6.0 to the 20 power of 23 magnesium atoms. React with 1 mole. 1 mole means what? 6.023 into 10 to the power of 23 oxygen molecules. Oxygen molecules to form What is that 2 moles of magnesium oxide? 2 into 6.023 into 10 to the power of 23 magnesium oxide molecules are formed. The meaning is this one. Okay, 2 moles, 2 into this number, react with 2 moles of oxygen. Oh, sorry, 1 mole of oxygen. So 1 into, or 1 into not right, need not necessary. 2 gives rise to 2 moles of magnesium, 2 into 6.023. That's the meaning. Okay. So anywhere if you get 2 magnesiums like this, the meaning is what? 2 moles of magnesium. 4 silver means what? 4 moles of silver. And 8 oxygen means what? 8 moles of oxygen. You have to remember in that way. Clear? So that is about the mole concept. Okay. Acha sir, now till here you said that it can be expressed in number, mass and volume. Then here, yes, you give the number, you give the masses, then what about the volume? Yes, now I will go to the volume. So see students here, listen carefully here. At STP, very important point this is, at STP, what is the STP? At STP, 1 mole of any gas, 1 mole of any gas, okay, occupies 22.4 liters. Very important point this one. And STP means what? Standard temperature and pressure. What is STP? Standard temperature and pressure. So what is the standard temperature? Standard temperature is nothing but 0 degrees Celsius. What is the temperature? 0 degrees Celsius. 0 degrees Celsius can be expressed as what in Kelvin? 273 Kelvin. How much? 273 Kelvin, because SI unit of the temperature is Kelvin. So normally we say that 0 degrees. Now what is the temperature today? This is summer, so almost summer. So today temperature might be now it is 35, 37, something like that. Okay, we express in Celsius, but actually the SI unit of the temperature is Kelvin. So 0 degrees Celsius is the standard temperature, that is called 273 Kelvin. Then what is P? Pressure. Okay, pressure is nothing but a 1 atmospheric pressure, or we can say that 1 Pascal. Okay, what you can say? 1 Pascal. Pressure is measured in Pascal. SI unit of the pressure is what? Pascal. So at STP means what? When the temperature is 0 degrees, otherwise you can write like this. When the temperature is 273 Kelvin and pressure is 1 Pascal, at that time, if you take 1 mole of any gas, 1 mole of any gas, this occupies 22.4 liters. How much? 22.4 liters. The meaning is what? At STP means this is room. For example, you think this is one room. Okay. In this one room, I am maintaining the standard temperature and pressure. Means here the pressure is 1 Pascal and the temperature is 273 Kelvin. Okay. Now in this I will take the different containers. What I will take? Different containers. And under these conditions, okay, in this condition, I am taking different gases in that containers. Okay, I will take oxygen gas, 1 mole of, okay, 1 mole of oxygen gas, hydrogen gas, nitrogen gas, anything like this, any gas I will take. Okay, now how much volume occupied this gas? This gas occupies, okay, 22.4 liters oxygen. How much this hydrogen gas occupies? Hydrogen gas also occupies 22.4 liters. How much nitrogen gas occupies? Nitrogen gas also occupies 22.4 liters. Means what? Under these conditions, under STP, at STP, 1 mole of any gas occupies 22.4 liter. That's constant. So, for example, if you see the previous slide here, okay, here you see 1 mole of hydrogen molecules, means hydrogen gas. So how much is 6.023 to 20.3 hydrogen molecules are there? Okay, so this if I express in the volume, then it occupies 22.4 liters. How much? 22.4 liters. Now here if I see in this reaction, 1 mole of carbon reacting with the oxygen to form 1 mole of carbon dioxide. 1 mole of carbon dioxide. Can you know that carbon dioxide is a gas? Okay, if I take 1 mole of carbon dioxide at STP, this also occupies 22.4 liters. Okay. Here 1 mole of oxygen, here 1 mole of oxygen. If I take the condition at STP, this also occupies 22.4 liters. So the meaning is what? At STP, At STP means what, when the temperature is 0 degrees and or 273 Kelvin and pressure is maintained 1 Pascal, then any gas occupies 22.4 liters. Clear? So now see students here, application of mole concept in your material, page number 101. The chemical formula represent 1 mole of substance. The chemical formula represent 1 mole. Okay. If I write 1 carbon, 1 mole of, just if I write carbon, C, the meaning is 1 mole. If I write sodium, the meaning is 1 mole, because there is no number is there, right? Now, 1 formula mass in grams respective mass of 1 mole of substance. Means what? Carbon, atomic mass is 12. If I take 12 grams, the meaning is 1 mole of, okay, carbon weighs 12 grams. If sodium atomic mass is 23. So, if I take 23 grams of sodium, that is equal to 1 mole of sodium, like that. 1 mole of any substance contains 6.023 into 10 to the power of 23 molecules. Just now I told you that. So, 1 mole of any substance occupies 6.023 into 10 to the power of 23 molecules. At STP, 1 mole of any gas occupies 22.4 liters. Okay. At STP, any gas occupies 22.4 liters. Okay. So, 22.4 liters. So, these are the applications of mole concept. Clear? So, that is about the mole concept. Right? So, that is it. And here one point is there. The formula mass in grams represents the mass of 1 mole of substance. Okay, let's see that also. This I think already explained, but once again. For example, I have a sodium carbonate, Na2CO3. What is the formula of sodium carbonate? So, if I written like this, okay, Na2CO3. So, there is no number before that. Okay, so the meaning is what? 1 mole. What is meaning of this one? 1 mole. So, the meaning is of this one is 1 mole of sodium carbonate. 1 mole of sodium carbonate. Okay. If you want in terms of number is same. 1 mole, anything it contains 6.023 into 10 to the power of 23, okay, sodium carbonate molecules, Na2CO3. And if I want the mass of this one, then what you have to do? So, you have to calculate the molecular mass. Already we discussed in the last class. How many sodiums are there? 2 sodiums, 2 into each sodium mass is how much? 23, right? Plus 1 carbon, each carbon mass is how much? 12, plus how many oxygens? 3 oxygens, 3 into oxygen mass is 16. Okay, now if you come to this one, 2 into 23, that is 46, plus 1 into 12, that is 12, plus 3 into 16, that is 48. So, if you add this all, you will get 106, sorry. Okay, 106 grams. So, here 1 mole of sodium carbonate mass, if you take, that is 106 grams. In terms of numbers, 6.023 into 10 to the power of 23. In terms of volume, no. Why? Because this is solid. Sodium carbonate is what? Solid. So, we cannot express it in terms of volume. We can express in terms of 1 mole means 6.023 into 10 to the power of 23. Sodium carbonate atoms and its mass is 106 grams. Okay. Is this clear to you? Chalo, right. Otherwise, okay. In terms of it is gas is there. So, now for example, I will take 1 mole of carbon dioxide gas, CO2. So, the meaning is what? It consists 6.023 into 10 to the power of 23 carbon dioxide molecules, the number. And its mass. So, you know carbon atomic mass is 12 and 2 oxygens, each mass is 16. So, 16 to the 32 plus 12, 44. So, here the mass of 1 mole of carbon dioxide gas is 44 grams. And in terms of volume, 1 mole of any gas at STP occupies 22.4 liters. So, 22.4 liters. Clear? So, 1 mole of carbon dioxide is equal to 6.023 into 10 to the power of 23 carbon dioxide molecules. That is equal to 44 grams of carbon dioxide. That is equal to 22.4 liters of carbon dioxide gas. Clear? That is. Okay. So, here questions are there. We solve the question after okay, continuous. So, this is a synopsis 2 students and we continue with the synopsis 3 also. Only one page is there. So, continue with the synopsis 3, right. So, in the synopsis 3, what is there? Chalo, synopsis 3 is also same. Okay, 1 mole of any substance contains 6.023 to 10 to the power of 23 molecules. Same thing is given here. Synopsis 3 you can see in the page number 107. So, synopsis 3. Open the page number 107. 1 mole of any substance contains 6.023 into 10 to the power of 23 molecule. That is a heading. Already we discussed 1 mole of any substance consists of 6.023 into 10 to the power of 23 particles. Here particles means maybe atoms, maybe molecules, maybe ions, maybe electrons or anything. Okay. 1 mole means what? 6.023 into 10 to the power of 23 particles. That's all. So 1 mole of hydrochloric acid. Example is given 1 mole of hydrochloric acid. So 1 mole of hydrochloric acid means what? Here 1 HCl. So just write HCl, because if you don't write number, the meaning is it is 1. So the stoichiometric coefficient is what? 1 for this one. So the meaning is what? 1 mole of hydrochloric acid. 1 mole of hydrochloric acid, what is, how much its weight? 36.5 grams. Why 36.5 grams? Hydrogen atomic mass is 1 and chlorine is 35.5. So 1 plus 35.5 is equal to 36.5 grams. And in terms of molecules, 6.023 into 10 to the power of 23. If it is gas, okay, hydrochloric gas also, it's also exists in gas. Generally it is liquid, hydrochloric acid is liquid, but it can be hydrochloric gas also will exist. If it exists in terms of gas, now at STP it occupies 22.4 liters. The meaning is this one. This only just now I told you here. Okay, 1 mole of carbon dioxide, 6.023. Number of atoms, mass, volume. Okay, so hydrochloric acid, mass, number of molecules and gas, that is. Okay, now 2 into sodium, 3 into sodium means what? 3 into sodium molecules. Okay, so that is there. Clear? So this is about the third synopsis, this much only stress. So at STP, 1 mole of any gas occupies 22.4 liters. Okay, and this is called gram molar volume, and the same thing, this is 22.4 liters. Achha, so with this, this chapter is done. Okay, so that's all. Yeah, calculations of mole concept is there. This will be learning in the next class, means in the higher standard. Now we are in 7th class. When you go to the 8th class, you will be learning, okay, how to convert, find the number of moles. You know, if the molecule's mass is given, how to find the number of moles. For example, here, this I am not going to explain you, just to calculate the number of moles. Okay, mole is equal to given mass by molecular mass. Given mass by molecular mass. I think some questions are included here. Okay, I will write the formula here. And in terms of number of molecules, if you want, the number of molecules is equal to, okay, number of molecules, number of entities, anything, number of atoms, anything. Okay, number of entities I am writing. Number of entities is equal to Na, Avogadro number, into number of moles, into number of moles. N means what? Number of moles. Okay, this is a formula. So, and here volume, if you want, okay, volume is equal to 22.4 liters into number of moles. Okay, so if any questions come, we'll solve by using these 3 formulas. By using these 3 formulas, we can solve the problems, right? Chalo. So with this, this chapter is done. Now let's go to the synopsis 2 questions. Okay, synopsis 2 questions. See, where is it? Synopsis 2 questions. Yeah. So synopsis 2 questions in the page number 102. 1 mole of any substance is equal to gram atom. Yes, in terms of you take the atoms, so that is a gram atoms. Where I written? First one. Okay, in terms of written gram atoms. Okay, and gram molecule. Yes, in terms of molecule, if you written that is gram molecule. That's also correct. Avogadro number of entities. Yes, so this is equal to Na, Avogadro number. So the option is the 4th option. What is the option? 4th option. So the first question, page number 102, the answer is the 4th option. Second question, the volume of 1 mole of any gas. The volume of 1 mole of any gas at STP. Come on. 1 mole of any gas at STP, 22.4 liters. Okay, what's the answer? 22.4 liters. That is the first option. Okay. Next, the weight of 1 mole of atoms of an element is gram molecular weight. Sorry, gram atomic weight. Atom is given atomic weight. If molecule is given, molecular weight. So option is the second option. Okay. The chemical formula represent. Generally, if written, just chemical formula is written. Na2CO3. The meaning is what? 1 mole. 1 mole. If any number is there, that many number of moles. So the option is 1 mole. The fourth one is 1. And the formula mass of V is, what is V? The gram molecular formula of not given, so that question is printed wrong, so leave it. Okay. Otherwise, you can take, if you take calcium carbonate, you will get 100 grams, and 53 is what? What you will get? 53. And this, 106 means what? Sodium carbonate. Okay, we discuss. See, 106 is then option, so 106 we got it here. So sodium carbonate. Otherwise, you make that question, gram formula mass of sodium carbonate, you make it. Na2CO3, you make it. So you'll get 106 is the right answer. Correct? Now come to the sixth question. The volume of any gas at STP, 22.4 liters. Even 22,400 liters also correct only, because 1 liter is equal to 1000 ml. So here 22.4 liters is equal to 22,400 ml. Okay. So the option may be both 2 and 3. So option may be 4. The gram atomic mass of carbon, 12. Already you know, this already we discussed. Okay. The answer is what? 12. Where we discussed in the first one, somewhere carbon, 12. Okay. The carbon, that is 12 grams, right? And next, 7.4 moles of iron weights. So here students, 7 moles of iron weights. So iron atomic weight you should know first. Okay. So iron atomic number is 27, but mass number. So what is given here? 7.4 moles of iron. 7.4 moles of iron. Right? So here you should know the iron atomic mass. Iron atomic mass, atomic number is 27. So approximately the 54 should be there, but there is no 54 something, it will be there. So just multiply with the 7. Okay. So iron atomic mass is 27 means what? Maybe 54, 55, 56, something around 56 will take. Okay. So here 7.4 into 56. Okay, you multiply, you get some answer. So 6 4s are 24, 2, 6 7s are 42 to 44. Again 5 4s are 20, 2, 5 7s are 35 to 37. 4 4 1 4 and point after one digit. So approximately students here 414.4 is the right answer, I think. Okay, check, this is the answer. It is there here. 414 is the right answer. Okay, how did you calculate? So iron atomic mass is 56. You have to remember that 27 56. 7.4 moles they said. So just multiply with the 7.4. Okay, you'll get the answer. Next, identify the correct options for the following. Formula mass of calcium carbonate is 100. That's correct only. Okay. Gram molecular mass of CaCO3 is 100 grams. Okay. Gram molecular is 100 grams. That's also correct. Formula mass of calcium carbonate. Formula mass of calcium carbonate is 100 grams. And gram formula mass is no. Here first and 2 are correct. Okay. How? So CaCO3. CaCO3. Ca means what? Calcium. Calcium atomic mass is 40. Plus carbon atomic mass is 12, plus 3 oxygens are there, each oxygen is 16, 16 3 is 48, if you add you will get 100. So formula mass, okay, they are asking formula mass, okay, we write 100 AMU because formula mass. If they ask gram molecular mass, okay, gram mass, then we can write 100 grams. So here the first and second both are correct. 1 and 2 both are correct. So you can take for the ninth one is both are correct. Next, STP conditions required. What are the STP conditions? Just now written here somewhere. Here 0 degrees Celsius or 273 Kelvin or 1 Pascal pressure. Okay. So here what options are given? 0 degrees temperature, 1 atmosphere pressure, correct only. 1 Pascal is equal to 1 atmosphere pressure. 0 degrees, that is correct. 0 degrees temperature 760 mm, that is also correct. Okay, because 1 atmospheric pressure is equal to 760 mm or 76 centimeters of mercury. This is also correct. I think This you might have learnt in the lower class only, okay, in the barometer. Okay, so that's also correct. And 1 degree temperature, that is wrong. So both 1 and 2 are correct. So 10th one is the right answer, students. Is this clear? Chalo. Now then go to the exercise 1 also, we check now. The number of atoms in 7.4 moles of iron ore. Oh, boo. So see now. What is given? What is given? Yeah. So here what is given? 7.4 moles of iron. 7.4 moles of iron. So they are asking how many number of atoms will be there. Very simple. 1 mole consists of, so see here, 1 mole consists of 6.023 into 10 to the power of 23. But how many moles they are asking? 7.4 moles. That is equal to 7.4 into 6.023 into 10 to the power of 23. Now multiply here with 7.4 approximate writing. So 6 4s are 24, 2 6 7s are 42 plus 2, 42 plus 44 into 10 to the power of 23. We can write like this, or 4.44 into 10 to the power of 25 also we can write. Okay, so anything you can write. So what is the options are there? 44.4 into 10 to the power of 23, 22.2 into 10 to the power of 23, 44 into 10 to the power of 22, 7.4 moles. Just have to multiply. Getting, sorry, here you have to keep the point, no? So here should be the point. Okay, so here 6 4s are 24, 2 6 7s are 42 plus 4, 44, and here a point after 1 digit, so you have to keep the 44.4. So this is the answer, 44.4 into 10 to the power of 23. So the first option is the right answer. Okay, the number of atoms in 1 gram of iron. Similarly, you can do it. Which of the following represent STP condition? Just now we discussed that 0 Kelvin or 1 atmosphere pressure. Second option is the right answer. And in a chemical formula, the symbol, the coefficient put in front of the formula is represents what? Number of moles, that is fourth one is the third option. And calculate the total number of electrons present in 1 point. Sorry, where is the page here? So fifth one, you say 44 grams of carbon dioxide occupy 22.4 liters at. Okay, so here how can you do? Which question this is? Fifth question. 44 grams of carbon dioxide occupies 22.4 liters at. Occupies 22.4 liters at. So 44 grams is equal to how many moles? That you have to calculate. Okay, so here carbon dioxide, just now I told you thing, no, carbon dioxide we calculated. Carbon is 12 plus 2 oxygens, each oxygen is 16, 16 2s are 32. So that is equal to 44. So 44 grams means it is nothing but a 1 mole. So 1 mole of any gas occupies 22.4 liters. Both are given, only they are asking condition. Condition is 0 degree Celsius, okay, 1 atmosphere pressure. Okay, so option is second and third option is the right answer. Okay, try to understand. Okay, next, the coefficient in front of chemical formula. The coefficient in front of chemical formula. For in front of chemical formula, if there is any coefficient, just now written, for example, 2 sodium carbonates like this, any coefficient is there, then what you can write here? Integer, yes. So for example, you see here, 7.4 moles means what? Here decimals also can be there, or you can see here 1 mole, so like 1 also will be there. So that may be integer, that may be decimal, that may be scientific notation, all the above is the right answer. Next, the formula mass is expressed in grams, is called gram formula mass. Okay, seventh option is first one. Okay, next, the 1 mole of calcium chloride contains, 1 mole of calcium chloride contains. So see student, this is also very simple. 1 mole of calcium chloride, 1 mole of calcium chloride contains. Okay, how many calciums are there? 1. So calcium is only 1. So the meaning is what? 1 mole of calcium. 1 mole of calcium is what? 6.023 into 10 to the power of 23 calcium atoms are there. Okay, but here how many atoms of chlorine are there? 2. So chlorine atoms are 2. Okay, so 2 into 6.023 into 10 to the power of 23. Okay, chlorine atoms are there. Okay, so the answer is what here is 1 mole of calcium correct and 2 moles of chlorine correct. So the eighth one is a third option, 1 mole of Ca plus and 2 moles of chlorine. Next, mass of 1 mole of methane, ammonia, water, or mass of 1 mole of methane, CH4, and next ammonia, and next to water. Just you need to find the molecular masses. Carbon is 12, hydrogen is 1, 4 ones are 4, so that is equal to 16 grams. Next here, nitrogen is 14 plus 3 hydrogens 3, so this is 17 grams. Water 2 hydrogens, so each hydrogen is 1, 1 2s are 2, plus oxygen atomic mass is 16, 2 plus 16 is 18 grams. So the answer is 16, 17, 18 grams. 16, 17, 18, the third option. The third option is the right answer. Okay, 16, 17, 18. Now last and final one, 2 moles of potassium chlorate weighs in grams. 2 moles of potassium chlorate is given. 2 moles of potassium chlorate. Now see, how many potassium? 1 potassium. Potassium atomic weight is how much? 39. See students, I said you to learn the atomic masses of up to 30 elements. This is mandatory to solve the problems. So here potassium is 19 atomic number, but its mass is what? 39. And 1 chlorine, chlorine is 35.5. And how many oxygens? 3 oxygens, 3 into 16. 16, 3 is 48. Now you add this both. Okay, when you add, what you will get here? Here 0.5 is there, so we write 0.5 here. And now 35, 39, 74, 74, 48, 74, 48, 74, 48, 122. I think 122 will get. How much will get? 102, 122. Yeah, 122.5. Now here how many moles? 2 moles. Just multiply with 2. So that comes to 225. Okay. Is there answer? 225 grams is there? Oh, sorry, 245. 22.5, no? 245. 2 into, so 2 5s are 10. 2 5s are 10. 0. 2 2s are 4 plus 1. 5. 2 2s are 4. 2 1s are 2. So 245 grams. The option is second option. Okay. So we are completed 2 exercises. Right? Once you check, just a minute. So right, now second synopsis worksheet we have done. Then we go to the third synopsis worksheet also. Okay. Third synopsis worksheet is in the page number 108 students. So once you open the page number 108, the weight of 1 mole of nitrogen dioxide, page number 108, third synopsis worksheet we are doing now. Okay. So third synopsis worksheet, first one, the weight of 1 mole of nitrogen dioxide. Nitrogen dioxide formula is NO2. So 1 means what? You need not to write. So 1 nitrogen atomic mass is 14 plus 2 oxygens are there, each oxygen 16. 16 2s are 32. 32 plus 14, 46. So 40 grams is 1 mole. So weight of 1 mole is 46 grams. So the first option is the right answer. Check once. Right. Next, the charge present in 2 moles of electrons is, this is a logical question students, 1 mole of electrons. Okay, 1 mole of electrons carries 1 coulomb, 96,500 coulombs of charge. How much charge? 1 mole of electrons carries, okay, 96,500 coulombs of charge. Okay. Now, 2 moles means what? You have to multiply with 2. Okay, you have to multiply with 2. So, 2 moles, they are given 2 moles. Okay, 2 moles of electrons charge is how much? 2 into 96,500. So, 0, 0, 2 5s are 10, 0, 1, 2 6s are 12, plus 1, 13, 1, 2 9s are 18, plus 1, 19. So, 1,93,000 coulombs of charge is the right answer. So, second option is the right answer, students. So, here you have to remember this point is not given in the material, but 1 mole of electrons carries 96,500 coulombs of charge. This you have to remember. Identify the gas whose 2 grams molecules weigh 64 grams. Okay, 2 gram molecules weighs 2 more. Okay, so here you see now this just you see helium atomic mass is 2. So 2 gram molecules is 64 grams. So 2 2s are 4. No, this is not. Oxygen 16, 16 2s are 32. Yes. Now take the oxygen here. Oxygen. Okay. Oxygen. Each oxygen atomic mass is 16. So 16 like this 2 are there. So 2 into 16 is equal to 32. So this is 1 mole. 1 mole. Now 2 moles is equal to how much? What we do? 2 moles is equal to 2 into 32 we do. So that is equal to how much? 64 grams, right? So they are given 64 grams. So the answer is identify the gas whose 1 gram only, 2 gram, third question. So 2 grams molecules weight is equal to 64 grams means that is oxygen. So the option is the second option. Okay, the option is second option. Now third one also see, identify the gas whose 1 gram molecular weight is 64. So helium is 4, oxygen is 16 to the 32, methane is carbon 12, 4 hydrogens 16. So I think sulfur dioxide is the right answer. Let's check. So sulfur dioxide, 1 mole of sulfur dioxide we take. Okay, so sulfur atomic weight is 32 and oxygen, 2 oxygens are there. 2 into 16 is 32. So that's equal to 64. So 1 mole of sulfur dioxide gas mass is equal to 64 grams. So the option is the fourth option, students. The fourth one is the fourth option. Next, at STP, 1 mole of any gas occupies 22.4 liters of volume. This already discussed, and it's called gram molar volume. See, that's only one word is there, volume. Second one say gram atomic mass, third one gram molecular mass, fourth one relative ionic mass. This is all different. They are asking the volume. So the answer is gram molar volume. Okay, that's the fifth one. Sixth one, which of the gas occupies 22.4 liters at STP? So here you have to again check. Carbon dioxide molecular mass, carbon dioxide molecular mass, carbon is 12, oxygen 16, 16 2s are 32, so that is equal to 44 grams. No, but first one is given what? 32 grams of carbon dioxide. So this is wrong. Then come to the second one. Second one, what is given? 1 mole of methane. Methane means what? CH4. So C is 12 and each of hydrogen is 1, 1 4s are 4. So this is equal to 16 grams. This is also wrong. Now third one you see both 1 and 2. Sorry. Here this is correct. Which one is correct? Second one is correct because they are asking 1 mole. Okay. So second one if you see, the second option is given like 1 mole of methane is given. 1 mole of any gas occupies 22.4 liters. So this is correct option. Okay. So second one is the right option, student. Now, which of the following molecule with the gram molecular mass is 14? You calculate here. First one is not because nitrogen is 14, oxygen is 12. So NO2. So you have to calculate the molecular mass and check NO2. NO2 is equal to 14 plus 32. So that is equal to 46. It will come. Second one is C3H8. C3H8. Carbon C12. 12 3s are 36. Okay. Plus hydrogen 8. So this coming to 44. So the option is the second one. Option is what? Second one. Eighth one. 8 grams of oxygen has the same number of molecules of. Okay. So here you see Oxygen molecular mass is 16. Okay, 2 oxygen, no? So 2 into 8 is equal to 16. So 16 grams of O2 is equal to 1 mole. But here it is given only 8 grams. 1 minute. So see what is given here. 8 grams of oxygen. 8 grams of oxygen O2 has the same number of molecules. Has the same number of molecules of what? So see now. Here what you need to do here, students, here oxygen O2. O2 means what? Each oxygen is 16. 16 to the 32. 16 to the 32. So 32 grams of O2 is equal to 1 mole. Okay. But here it's given how many moles? How many grams here? 8 grams only. 8 grams of oxygen is equal to how much you'll get? 1 by 4 mole. Correct? Okay. So you'll get 1 by 4 because 32 if you divide it by the 8, you'll get 1 by 4. So 1 by 4 mole. Okay. Now you calculate the remaining gases what are given. 7 grams of carbon monoxide. 7 grams of carbon monoxide. Carbon monoxide means CO. Carbon is 12. Oxygen is 16. 12 plus 16 is 28. Yeah, this is also correct only. Okay. So 7 to 28. So 1 by 4 you will get. So the answer is 8th one is first option correct. Second option also will correct because 11 grams of carbon dioxide is given. 11 grams of CO2. Carbon dioxide is 44 divided by 11. So you will get 1 by 4 only. Okay. Third one is given 7 grams of N2. 7 grams of N2. So N2 is equal to nitrogen is 14. 14 to the 28. So if you divide 7 by 28, you will get 1 by 4 only. Okay. So here also we are getting 7 by 28 is equal to 1 by 4. Here 11 by 44 is equal to 1 by 4. Here 7 by 28, you are getting 1 by 4. In all the cases, you are getting 1 by 4 as this. 1 by 4. Okay. So the option is all of this. Next, number of moles present in 56 liters of oxygen. 56 liters of oxygen. Number of moles present in 56 liters of oxygen. Correct? Yeah. So 56 liters of oxygen contains how many moles? Okay. So here you say 22.4 liters is equal to 1 mole. Right? So 56 moles is equal to how much? Cross multiplication. X is equal to 56 into 1 by 22.4. So if you cancel, how much you will get? 22.4 into 2.5 if you do 2.5, I'll do what I'll get? 25 4s are 100, 10, 25 2s are 50 plus 10, 66, 25 2s are 50 plus 56. Yes, I am getting 56, so 2.5 moles. If you divide, X is equal to, you'll get 22.5 moles. Okay, once you check the answer 2.5, yes, 2.5 is the right answer. Next, the volume occupied by 1.5 moles of carbon dioxide. The volume occupied by 1.5 moles of carbon dioxide. 1.5 moles of carbon dioxide. You know that 1 mole is equal to 22.4 liters. 1.5 is equal to 22.4 liters into 1.5, just multiplication. 15 4s are 66. 15 2s are 30 plus 6, 36. 15 2s are 30 plus 3, 33. Point after 2 digits. So the answer is 33.6 liters is the right answer. Is that? Yeah, second option, 33.2 liters. Okay. So like this, students, you try to solve the problems. Okay. So remaining sums you try. With this, we completed this chapter. And here, wherever you have a doubt, not a doubt, whenever you are solving these sums, just you pause it. Okay, pause the video and and then you see, for example, this 2 moles of potassium chloride is how much? If this question is given, if you want to do it, just pause it and see 2 moles of potassium chloride. Potassium atomic weight is 39, chlorine is 35.5, 3 oxygens is 48. If you add, you will get 122.5, and 2 moles are there. So 2 into 122.5 to 45. Like this, just pause and do it. Still, if you have a doubt, we'll have a doubt session because the chapter is, the portion is done. With this, the total syllabus of volume 2, 7th class is done. And already I think you received one question paper of chemistry from the first chapter. What was the first chapter of yours that you have received? And similarly, we'll send some question papers like to practice. So as a practice test, you can write it, and we'll have a doubt clearance section from that video, that question papers. Okay, and if the after completing the portion of all the classes, then we'll have the revision classes for your final test. Clear? So bye, take care.